So let me actually start my session of that assembler in the assembly process. Let me get started with that. So my assembly program is actually available in the D file in the SPH folder, and here it is the assembler folder, which is actually containing all the assembly program. This is my CD program. Let me open it with Sublime Text. Okay, this is my Sublime Text. What? Okay. It is still loading, and here is my Sublime Text. Sublime Assembler is actually a program in which we have to actually write all the stuff which are related to assembler. So these are the programs for that assembler one. We have different ones which are also working for the assembler, but yes, it is actually the main program for that assembly process. And let me actually try separating it into another file. So thunder assembler recipe. Let me make a new file and we'll name it something say assembler .cpp, right? And let me copy the code for the assembler. The code is actually a long one, and it is actually starting from here, then up to this place, right? And actually ending up to this place. So that's actually a long one, so I'm actually pasting this stuff here. So this is actually pasted here. So this is my code, which is an assembler code. Let me actually try running it. If I go to GCC, if I go to this D directory, right, it will actually also require an input file. Input file will be something so called that is actually source file.asm, which will be actually open here to src. So I will make another file here in this directory source.asm, src.asm. Sorry, it will be saved with src asm, and let me actually keep it here. And the other code here will be code that will go here will be actually start from this start 01 to this end code. So this will be my actually code which is needed to be assembled. So let me actually paste this code here, and I will get some output. This doesn't require any other things, but yes, I need to change the reference from source file to asm to say to say src.asm. So this is actually opening in this dev cpp, which I didn't like much. So I will actually open it with Sublime Text because this is a bit more clear. So here is my Sublime Text. I'm going downwards in the anti-main section. Where is my anti-main section? And I'm actually opening a source.asm. Right, that's actually my file. Sorry, source.asm, and that's actually opening the read mode. And the destination file is actually made for writing the things out. So this is my assembler.cpp, and if I try running it, I will go to my command, and then I will go to spHW, that was the name of the directory. And if I will go to here in this system, I have another folder that is actually equal to, let me show you that folder. This is actually um, assembler directory here. So I will actually change my current directory to that. The case doesn't matter at all in the command. Yes, we are in here, and now we'll try GCC. Well, it's a C++ program, so I must use G++, and with what say assembler, not cpp, and it will run. And okay, there are a lot of say issues with it. So let me actually try naming with that .cpp. Okay, opened up. Here is my code. So let me try running it. Control F9 F11. Right there, here it is my code. F11. Okay, so I must use function keys on F11 to actually run F12 not. What's the problem here? Okay, so there is a bit problem here, like this one. So yes, fixed now. And let me actually try by doing it again. Okay, so there is problem in this statement also. Okay, so these have been shifted because of copy paste. These have been shifted a bit. And error plus F11. This must also come here. I must actually fix them on before actually making a video. Okay, so pausing for a moment. So yes, there was only one tool notebook, so it is my assembler new program here. Let me actually try making it a bit large. So it can go, yes, it can go down right like this, and also, well, this is not at all needed. So this is my assembler program. Let me actually um, try making a font a bit larger, so size will can be increased. Like sometimes that's 18 is fine. Okay, so this is my program. Okay, so this is actually assembly program. So firstly, I need to define string as usual, string and continue. String is also used, and string is for the integer to character conversion. Number of tokens are actually equal to 5 because we have actually 5 tokens in one line. Now let's have a look at our assembly program that is actually sourced into assembly. We have to actually assemble this program. So right, um, we have this program, so number of tokens are actually equal to 5. I don't know why I have kept that. I didn't remember, so that's actually my start 101, my start 101. And then start is actually a symbol, not a command. Means I think that is command. Then we have move, so I can actually shift them with the tab space like this to actually show them as a command. So start is actually a command telling the start address. Move and brg, then again. So I think that yes, we must actually move them a bit also here, so that it is a bit clear that how we are actually manipulating all the stuff. So move AR is actually a command, right? And mul is also a command, right? This way, and add, moving it to this way. So move M is actually a command, and compare is also a command means operation. So yes, BC is actually a branch instruction, and then we have move M, which is also another instruction. Print is also another instruction. Stop is also another instruction. Label is only one, like this start, or we have another label, say this N, and then we have this ds. We have these types, like these are of define something, let's say string. I don't know, define storage, and we have the define character, maybe one, and then we have another dsa. So manipulating all these stuffs like this. Okay, so we have defined the first symbols, like these are the end symbol. So and it will also come here because it is also an instruction. And okay, so these are the commands which we need to actually manipulate. And okay, so the first things after these will be actually, say, first things will be something which is actually first operand for these instructions, and this will be actually a register, some register, or say some memory location. Memory location can be given by using exact code or hard coding it, or we can also use another register like CREG, or this one as BREG. We have four registers here: AREG, BREG, CREG, or DREG. Means REG means a register, right? And we can use some memory locations like N, which is actually defined below, right? So it is actually an implementation of a two-pass assembler. So the second operand after it will actually be 1. This term is also another operand, and term is also another operand, which is actually defined below. 1 is actually there, and the term is also there. And now we are talking of n is also defined below. Now again is a label for which we will find the address, and the result is also a label, or say identifier, which we have defined below. And yes, here is another result, so which is actually only the first operand. We have noticed that some instructions require only one operand. Some instruction doesn't requires an operand at all, like this stop or an end. And this set is actually ending character of my current file. And yes, we have actually just manipulated to actually write them in this way. So move ER, this will be actually combined in such a way that we have been given the first, this 101 as the starting address. And yes, this starting address will start from this place, and then it will be actually 102, 103, 104, 105, 106, 107, 108, 109, 110, 110. Then we have 111, 112, 130, 140, 115, 160, 170, and 180, 190, 190. So address will be up to, say, 190. Sorry, this will be actually not given any address, right? We have not defined any address. We will not give any address like this. We have to actually mark them as. But if it is a space, let me see if it works. This also now. Let me see if it also works still. So let me actually try compile it again after just a bit of manipulation. Let me see if it works. If you open the file, it has actually been changed. So yes, it is still working. That's also cool. So yes, we have manipulated all the stuffs around there, right? That's copying from one file to another file. And yes, the line spaces doesn't matters. It actually will look for the whole line that if it is only a single line with no character at all, then yes, it will actually go to next line, but it will not give any address, and that's actually specialty of my program. It will first separate all the stuffs which are actually needed. So comma here will be fine. If I also want to give a tab space here, then there is no issue. Yes, comma, and then we have second operand there working there, and then we have firstly the first operand. Okay, so it is not working. So yes, we have this as a second operand, and the comma as a separator. And talking about this stuff, these are also the operand for these pseudo instructions, which actually just define me the storage, right? The initial value or the storage, how much storage is required. Define storage with the one value of storage and define character that they're actually defining a single character and getting and initializing it with single character doesn't need to be initialized such as array. But yes, it is actually initialized with this character, so it is fine. Let me see if it is working still after a bit of manipulation. So we are doing the similar session now. So yes, it is still working. And okay, so instructions. Okay, symbol table is actually not working. I don't know why, but okay, symbol table is not working at all. There are some problems there. Okay, these are not working at all. I will get the data in the raw form like that what I have found. So I have done this manipulation on the basis of that stuff, but I need to actually give the program without any spaces at all, because space are the characters which are there. So I need to actually get the code again from that file. So this is actually my file, copying this stuff up, and yes, copying this stuff into this um, file and name it with saving it with source file dot asm, and that's on source file dot asm, and talking about this on the assembler.cpp, and source file dot asm is actually where is my assembler file? Yes, here it is here. I'm talking about that file which is actually being referenced as source.asm. I will write it as source file.asm, and that will be actually F capital. So let me actually try running it again. Yes, no issues because I hadn't changed anything. So now I'm trying to compile. Yes, all the things have been compiled. On the basis, I have written the program on the basis of that file. So yes, it is working on that. Adding some spaces are making some irregularities in that program. So file.asm looks like this with some line spaces, and yes, it is working. No issues. So let us see that how this program is working. Going towards main is our starting of the program. So where is our main function? Yes, it is our main function. We are using find, which actually comes under, I think, is iString. So I don't need to import any other library for it. So find star fs, and we used to open the source file with the fss pointer, and we used to open the destination file with the fts pointer. We have to actually traverse all the characters of this file. So first step is actually to traverse all this. So we will take the character ch as the character, and we will use the fgetc function with that file source pointer, right, to actually get a single character from that file, from the start of the file. The internal pointer will actually keep on moving forward so that we can get more and more characters, and thus we will use the different stuff. Use a while loop. While character ch is not equal to eof. Eof is actually a status that actually turns on whenever we actually encounter the end of file character. End of file is actually like a static member which might be defined in some of the header libraries, I think. It is actually means defined in the I stream, I think, because okay, so maybe in the F stream, I don't know much about it, but yes, it is defined in some of the libraries so that it can be used as a character which actually encounters when the end of file is reached. So where was my program? Yes, going to my int main. Yes, where was my while loop? While character is not equal to EOF, I will first try to convert all the stuff which is actually shown here in the small letters into some capital letters. So yes, it is my if character is not equal to is greater than equal to a and less than equal to z, then I will just change it to uppercase. How I will do it is actually character intx will be equal to I will typecast the character value which I have got into the integer value so that I can get the sky value of it. And I know that the small a to small z are actually from 97 to 122, and my capital A's and capital Z are from 65 to 90. So I will there is a difference of 62. So I need to actually subtract 32 from its sky value so that I can get a capital letter. So yes, let's change it to the capital letter. So I will minus 32 from it, and I will typecast into a capital letter. And yes, my character is actually just changed to a capital letter by this if condition or if braces. Now I had been printing all this stuff, but if it is actually a space or say a comma, if it actually a space or a comma or a backslash n or a at rate, right? Like this, I will say word start is equal to 0 and something like that. I'm actually trying to parse all the words. So if I figure out, then I think that yes, all the words are being separated with the space, right, or a comma, right, or what is there to actually separate another word in this file. There are at so at is actually ending character, which is actually different stuff to actually do all the refresh or stuff for the next line. But yes, there are some words or say some space which are actually separating all the words, and some comma also there to actually separate two words because there are no space between them. So these are the character which are actually separating all those stuff. So I've done if condition here. So defining the sum of the stuffs, these are actually the variables defined for those stuff. I think I had defined the MB index, means main buffer index, to actually use in line buffer as a line buffer as the 100 with the 100 of max value is there, and it's used a string character there to a string variable there to actually count, to actually store the particular word which we are actually parsing from that file. So we will understand these one after another. Firstly, what is my main logic here? Is to actually collect all the values in a single file, right? We have to actually collect all the values in a single file. Then this whole line which is actually collected will actually go into another main array. That is actually my main buffer there. So all the values in a single line. Firstly, I need to actually get a single word. Then after the separation, that is actually a space, I need to actually get another value. And whenever I will reach an ending character like this backslash, and here it is somewhat here, so that is actually going to next line. Then I will need to actually traverse that what I have figured out so far, and that is actually my line array. That is actually stored in my line array, right? So that's why I will just get a hold of okay, so this is actually a struct which is defined by me, and this is actually a struct which is actually defined by me, and taking all the stuffs into a single line will be actually stored into a string array, right? And these all stuff which is representing a single line in which we have different string values. We have max 10 as values. Well, we can have max I think 4 1 2 3 4 4 string values, but for the sake of easiness I have just kept 10, so that if I just change my instruction set, then it will be also eligible. My current program will be also eligible to actually compile. I just need to make a bit of small changes while processing the stuff. So yes, so let me show you the line buffer. Firstly, let us have a look at counting all the words in the current line. So yes, I have already changed the small letters to upper letters, and now I have actually seen that yes, whenever there is a backslash n or say something else, if it is something like that, that if condition will run after it. But yes, I think that I must actually come to this condition after this else, because firstly, you are, whenever you are starting some to traverse some program, you are trying to get tokens and you are not actually encountering any space, so this condition won't work. So let me go to the else part first. I will say that you have, otherwise if you have something else, then you have not encountered anything, then you will say like word start is equal to 1. Word start is actually an integer which is defined as just like a counter or say tweaker value, which actually tweaks to from 1 to 0, to actually state some different condition. In the start, word start is equal to 0 state that you are not counting any word till yet. But when word size is equal to 1, that it means and I have just done the word start is equal to 1 in the else part of this if condition. This if condition states that you are encountering some of the delimiter, but yes, its else part is something here which is actually saying that if you are not actually getting any delimiter, then you are actually counting some of the word, or you are actually counting some of the token till yet. So word start will become 1, and according to this word start, right? So according to this word start, you will say that if word start is equal to 1 means if you were counting something, then s was actually a string variable in which you will just add on then character, right? You will just keep on counting this stuff, and then you will do what is, okay, you will keep on counting this stuff and this stuff, and whenever you some space is reached, okay, so because of this condition you will count start, all this stuff will be actually counted into this or will be added into a string s variable, and then you will encounter this space right after start and before 101. Then what you will do is actually, okay, this is actually running like a while loop, yeah, running in a while loop, yeah. So it will again come to this place and convert all the space small letters to capital letter, but space is not will not come under this condition, so you will go to this condition. And yes, it is a space, so yes, it will come to this, and now you will say that word size equal to 0. Yes, your counting has been stopped, your counting has been stopped, so you will not add the space to your word, and thus now you need to actually store this word what you have counting, that is actually start. You need to actually store this one. Now you will compare that, have you found something. So s dot compare with nothing is not equal to 0, means if it is something in s, it is also possible that you have encountered a space after nothing, means you have just encountered space after nothing, so it will just go before after this. But yes, you have encountered something, you have encountered a start, means you have counted a start, so you will in your line buffer, you will do what is actually line word index plus plus is will be equal to s, means I have kept index here, that is actually line word index will which is, whose initial value is equal to 0, and then I have made a buffer that is actually array of size 10 into, means in a single line I can have 10 tokens at max. I have kept this condition, well I must keep 4 here, but yes, I have kept 10 for the sake of simplicity, and it is of string type, so it will store 10 strings, so its index will be incremented, and in this buffer my string will go. Okay, so going downwards I have this. Okay, so if this will keep on going and this index will keep on increasing, and you will count what, in this way you will count the start here and then 101 here, so these both will be counting, and after that a backslash and will come like this, a backslash and will come at this place. So yes, whenever now when it will come to this condition, right, because this also contains a backslash n, so it will say that yes, if backslash n comes, right, if some backslash n comes, and now string variable will contain nothing, because you have just stored the last, say 101 here, and then again loop runs, and then a backslash n comes, and now the string variable was actually cleared to 0, means nothing because of this condition. Yes, it is actually being cleared to nothing, because you see that these if conditions run from this place to this place, and at the end we are actually clearing the s variable to actually store the next value like 101. So okay, it is cleared, and now you will compare that if it is actually equal to means if it is actually equal to this, then you will not store the nothing value into your line buffer index, right, because you don't need to store nothing. whenever you have something, so it will be not equal to 0, it will come to this condition and will store, otherwise not. So if it is actually a new line or a trait, because that's actually the ending character, I will explain later. So if it is actually a new line, then you will do what? Then you will do what? These are the if braces, yeah. So you will do what is actually if line word index is not equal to 0, means if you have counted something on that particular line, then you will do what is actually make a struct that is actually equal to line with mb index, right? MB index actually points to the current index value, or say MB index is actually representing a particular line in this program. So for start, it is representing 0 line, and for this second line, it will actually represent 1 value. It is actually like an index. For the first line is 0, this for the second line is actually 1, for the third line is actually 2, and it will keep on going till end whenever my file encounters some of the characters. So yes, it will actually make a struct here with the value of L. Yes, it is the name given to this line, means line for the line I have given capital L. And yes, I will show you the struct which I have made for this. So here is my line struct. Here is my line struct, in which I have an empty constructor which does nothing, because I need a constructor with the line number, and the line number was the MB index there, and then it is actually being copied to the line number, means which line it is actually representing is actually stored in this line number. And then there is a copy method which I have created in it, which actually does what is actually, this is actually an array of that particular line, means the line which was storing all the tokens is actually taken in this, and then there is another length variable which will actually show that how many tokens are there in the line. For the first line which we have parsed, there will be 2 tokens, right? So the length variable which will be actually passed here will be 2, and the line buffer will be the buffer of that line which was actually being passed from here. So according to the length, you will copy all those tokens which you have found in a particular line into this token array, and the token array is actually made as a string, and the number of tokens here. So number of tokens I have kept here. Now here comes the role of this hash defined number token. I can just make an integer variable, but yes, for the sake of more professional work, I have done number of tokens with the value of 5, means I can have max 5 tokens in a particular line, as I have seen so far. At max I'm just getting 4 tokens in a single line, but yes, I can actually have 5 for the sake of easiness and safe so that I can actually extend this program whenever I change my language. I've kept it at the value of 5, so a string array will be created with the value of 5. Now I will copy all the tokens which I have encountered in a particular line to this token array when I will call copy. So let me actually show you that where I was doing this. So yes, I had came to this place, I have created a new line with this line struct, and then I have copied this line buffer which is actually storing one start and one 101 value. So these will be actually 2, and the line word index will be my actual length will be treated, because the line word index was actually being incremented after just inserting the value. Then now 0th value has been inserted, 1 value has been inserted, and after 1 it has been incremented to 2. So yes, 2 will be actually passed here. The line buffer will be also passed at the first. So main buffer. Now this line is actually being stored. This actually L represents a single line, and that's why I need to store this whole line. I need to actually store this whole line so that I can actually get all the lines here, right? All these lines must be stored. So I'm making another array of lines, right? I'm making another array of lines that are actually line main buffer with the value of 100, so that I can have max 100 lines in my program. You can actually change it according to your needs and requirements, and that's actually my line type array. That's actually main buffer is being used here of the line type which I have shown you, and this is actually main buffer, means this is the array, and this is an array of all those lines. So yes, line buffer, where was I? Yes, main buffer index I plus plus will be actually another thing. So yes, mb index was actually passed here, which was actually 0, which was an index for 0, and it will be incremented, and for the 0 value, before incrementing, its 0 value will be used for inserting this particular line. Means it is actually a type of line, so it will store lines. So yes, this is also another line which is actually storing all the tokens still yet, and I will store the value of this line into this main buffer. Now line word index will be actually equal to 0, because I need to actually, whenever I store a new line, then I need to actually refresh the value of line word index, so that I can actually copy all those stuffs again into a one array. I'm not making more arrays. I am just using a single array. I'm just using the index to actually store all the stuff. So if I am clearing like a stack, it is actually working. So if I am actually clearing all the stuff to 0, so it will actually start storing the things from the index 0 from the next time, and also my all the values are being lost in a one, in a sense, so that I can not access them. So yes, I'm actually doing this for actually storing the next line tokens. And yes, after every space I encounter, after every space or after every comma or after every new line I encounter, I need to actually clear the string array which is actually storing all the tokens. So yes, in this way this will keep on going, and this will keep on going again and again. And yes, we will actually, okay, so effort C will actually, when it will keep on going again and again, and I will traverse this loop, while loop, and it will store all the tokens into my file. So yes, this is also necessary, because in this while loop you have only got one character in the start before this while loop. Let me show you. Yes, this is my while loop, and you have got only one character by this statement, right? And you now need to get new characters, because this will keep on the infinite loop. So I don't need it. I want to get another character, so I will go and say character ch is equal to f get c with fs, means file source pointer as my value. And thus it will keep on a while loop until the end of file is reached. Now in the next phase, this was all the parsing phase of my program, right? It was all the parsing phase of my program. So now the number of lines is actually equal to mb index, and now I will need the number of lines, means how much lines I have got in my program. So let me see, in my source file I have got, say, I think 20 lines. And so it will actually parse all the stuffs. Well, these are actually not the 20 lines, because this is actually not a line, and this is also not a line. So whenever you actually traverse that a blank line has been created here, so you need to skip it. So yes, we are already doing it. Whenever we see that, yes, some, if we were doing, yes, if line word index is not equal to 0, means we have encountered some of the tokens, some of the words are there in your storage, that is actually line buffer, then you are actually incrementing this mb index. Otherwise, means this is actually a line index, so you are actually incrementing only on that. So whenever it will encounter the space line, means nothing in this, so mb index means line buffer index will be actually equal to 0, and the line index will not be moved. So we in total we have total say 17 indexes in total, right? 17 indexes for the 18 lines, and the line and the last we will be incremented with 18 as because it actually increments for the next line, like mb index plus plus, that is actually post increment operator. And then this index operator will be actually used for the length. So now it will be actually at 18 in value. So we will use the 18 as value in this number of lines, because it would actually represent the number of lines, and number of lines is actually made on the top here. Number of lines is equal to 0. That's actually an integer global variable which is being made. So yes, now I have parsed all the tokens. I have parsed the string with the tokens in my input file. Now I can actually process this file with my internal processor. This is actually a function which actually passes the main buffer here and the main buffer index. These two values are only being passed, and these closing function are just for closing the files in which we are writing in the file. I will show you that stuff in the next section. Well, okay, let's continue this session only. So yes, my first argument is actually main buffer index, which is storing all the information which we have traversed so far. That is, it is containing all the lines, and the main buffer index is actually the number of lines, actually, right? Number of lines till yet parsed. So yes, now I will go to my Thunder processor. Now the main work start to actually starting or initiating of converting to assembly code. I've also made a show function into my say line struct that actually shows all the tokens and with the tab space, right? It actually shows all the stuff with the tab space. So if I'm actually using the show function for the main buffer index 0 part, then it will actually show me start and 101 as the result. So okay, so just leaving this stuff, I will go to the Thunder processor, which is actually using all of these structs. So where is my Thunder processor? These are actually for the help. That's why I've created in a way of okay. So this is my actual function, the Thunder processor, which in which our first argument is actually a main buffer, which is offline, and I need to actually get the length also, that how many lines you have stored. So this is actually stored in the line variable. Firstly, before actually doing the assembly work, I need to actually get all the mnemonics. Means what are actually the codes for the different mnemonics. Mnemonics are actually these instruction names that actually read, start also needs to have a mnemonic, move, er, move, am, mult, then move, er, add, move, em, compare, bc, and something like these. And then we have so we have different values for it, so we will get those values into my program only. So I'm using a mnemonic type. I have also made another struct that is actually mnemonic, and I'm making a pointer type to it, that actually it will store a pointer. A pointer to a pointer means I will explain this, and the get mnemonic function is actually returning a pointer to a pointer, and which is actually stored in mnemonic. Means it is like a kind of 1D array. It is kind of 1D array which is actually storing objects of mnemonics. Then I will go to this get mnemonics function. The get mnemonics function is actually where is that? Yes, here is my function. So I need to actually say that I have made say 11 mnemonics in my assembly hypothetical language. So mnemonics, get mnemonics is there, and then we have mnemonics mn is equal to new mnemonic of say 10. So I'm making say 10 mnemonics, and I'm actually passing on the values, like this is actually the name of the mnemonic, and this is actually the value. This is another name, and this is the value, and in this way I'm actually just passing on the value. And where are these going? I'm actually making a type of mnemonic, right? I'm actually making a type of mnemonic. So yes, I am actually making a struct of mnemonic. So here is my struct, small struct of mnemonic, in which I have empty constructor which does nothing. Now we have for every mnemonic we have a opcode and a code for that mnemonic. Now passing on the opcode and the code here, this start opcode will be equal to opcode, and this reference code will be actually equal to code, and there is another function. We can also pass through a constructor or say a set function in this mnemonic struct. So the set also is passed with opcode and the code value. The opcode is actually this dot opcode will be equal to say opcode, and this dot code will be equal to say code. So right in this way I will have this struct mnemonic. So it will be actually set up with set function or say constructor. I have used just a constructor, right? With this way, firstly I have made an object, like I have made a reference, means like a pointer to a pointer, double pointer reference, double pointer to actually store a 1D array. 1D array of what? 1D array which will be actually storing objects. Like objects also need to be stored in a pointer. So that's why one pointer is needed to store one object, and for 10 pointers we need another pointer which is actually pointing an array of 10 pointers, right? There is one pointer which is actually pointing to an array of 10 pointers, and in those 10 pointers if we look at one pointer, then one pointer is actually storing this mnemonic, means this object, because objects can be stored or referenced with pointers in C++. So yes, it will be a two reference pointer there. So yes, in this way we are actually getting all those mnemonics with the values or the opcodes, and we have different stuffs here, right? We have not included the start in this mnemonic because it is actually just stating at the start. We will encounter for the start in the different scenario. So yes, now I will return this mn which I have made here, and I will return mn, and mn is actually of type double pointer, so I have actually made it in like other function. So it will actually be used there in another processor. Yes, here it is get mnemonic. Similarly, I will get the branch codes. like BC, I will get the branch codes. So branch codes, I will go to here, get branch codes function. Where is the get branch code function? Okay, here is my branch code function, which is actually say get branch code and it returns BC. So I'm making new branch code of the BC length. That's actually okay. I'm actually we have different branch codes here. That's actually less than equal to greater than equal to or any. We have 6 branch codes here. So we are making a struct type like we have done for mnemonic. We are actually doing again for those branch codes also. So yes, we are doing this, and we have to actually make a struct again. So where is that struct? Okay, so mnemonic struct is actually here. I think I have made, yes, here is our branch code struct. So branch code struct has an empty constructor which does nothing. Now it also has a opcode and another code value, which are of string types. I'm doing this in the string type because they are easy to handle, and whenever I parse some int from the string, this is also another easy function. There is another one I will explain below. So I have passed an opcode here and a code value here, and this dot opcode will be actually equal to opcode, and this dot code will be actually equal to code, and the set function will actually set the opcode with the code value, right? So the code value will be actually set with the opcode and the like this way, and opcode will be also set. So opcodes are these one, and their respective codes are these ones, right? For the hypothetical language, it is not actually some actual language in use in assembly or architecture, but I'm actually considering it so that we can actually make a new or say real assembler also according to it. So yes, so we have also got my branch code array like the mnemonic one. Every pointer is actually storing, and these all pointers are actually referenced with a dynamic array of a pointer made with this. Okay, so this statement says that new branch code star of branch code means we are actually getting an array of type pointers with the length BC length, right? So these all will be actually stored into say this variable BC. Okay, so now actually traversing all those lines, right? I'm actually just printing all those stuffs for the this for loop just for the sake of debugging. I'm just printing up. Firstly, I'm getting one line from the main buffer because of the length array actually contains all the lines. So I'm just printing all the lines and getting them into a line, and I'm using lines.show function, which will actually show or print all the tokens which I have explained earlier. Now the symbol table. Okay, so now symbol table is actually being constructed. So I have this symbol table line, which is actually made for this one. So I am actually constructing this in a similar way. So I made a struct for the symbol table line. Where is it? I have this as a symbol table line, and symbol table line has an empty constructor, right? This will actually represent me some stuff. This will actually represent me some stuff that it has some opcode equal to something, the registration register code value be equal to something. So it will store some codes, means it will actually represent a single line of your symbol table, means what is actually the output of your code will be actually like this. What is actually being shown say with this value, this single line will be actually, this line will be actually represented by a symbol table line. The first value is actually equal to address, and the second value is actually equal to opcode. The third value is actually equal to some say your register code. Sorry, for each third value is actually your first operand's code, means if it is actually a fixed code, then it will be actually got by these first if it is actually a fixed one, it will be actually got through here only. But yes, if it is actually some label, then we will look at the address of that particular label, and we will just insert its address here. Then we have this, which is actually the second operand, because our instruction is in such a way that it uses two operands, one opcode, and this is actually address. So this whole line will be actually presented by this symbol table line struct. Okay, so I have the line address first value here. I have the value of this means opcode. What is the value of this opcode here? I'm using this, and I'm using the third. And the third as this actually must be. I've used the okay, I've used the register as the variable name. Register BCD means register branch code. Register or say branch code are actually common, so I've used for the first operand I've used this name like this way. If we see that we have this register or say some branch code here like LE, right? In some instruction for the first operand we have say branch code, right? This is actually the operation and this is actually the branch code, so I've used a variable name that is actually register or say branch code to actually store the actual value, and the last where address will be actually some address, because I'm actually observing. This is all the things of observing. So last where address are actually what I have seen so far. They are actually one, or say about term, or say here term and one, and then another n, then again. All these are actually some labels here in the last field normally. So I am actually just using an int here to actually store them as a number, and these of course are actually parsed as strings, so I'm using as string because I'm actually returning the strings from here, from there, not the actual numbers, so that I can parse accordingly. And now if I have to set the line address, then I have made a function, right, to actually set this. This is a line address is equal to adr, and then another get method for that. This dot line adr will be actually line address will be actually returned. Setup code has another function which is actually string code. This is a code is equal to opcode, and then similarly the set r register branch code registration or the branch code RGBC. This is RGBCD is equal to RGBC. Then we have to say we have another function for say set last where address, and int is actually the value, and this the last where address is equal to address. Okay, so this is the stuff. Now let's see that this is actually the number of lines is actually the MB index, and this is also passed here with length, but for the sake of simplicity I've used the number of lines, which is actually a global variable which is being set already. So now I have created just a pointer to a pointer. It is not storing anything here, so I have to actually make new objects of symbol table line. Means we have to create the particular number of lines, mean number according to the number of lines we have created that number of lines, and we have to insert it into this symbol table line object double pointer to actually store all the lines with the initial value of say 0 0. So firstly this must actually store just the 0 0 values with nothing, right? We actually store only the 0 0 values all around. Now I have to actually find firstly the now my parsing work starts. How do I used to do that? Firstly I used to find a start variable, and then I used to say like I used to say like something that yes, whenever I find some start variable I will say that what is actually the start address, and I will use this start address for the start address of my instruction set. And yes, I used to increment one after another as I'm considering just whole instruction to be one byte, so I'm just incrementing for the sake of easiness by one only. We can also use different stuff here, and then I will mark this as 101 or so. Let me show you. In the final code we have something say like 101 for the first line means this actually start, and 102 for the second line, right, and then 103 104 and similarly all those stuffs. Okay, so let's see. Then now we have the number of lines. We have line L is equal to main buffers L part, means we are actually inserting a single line into this L variable from the main buffer which we have stored so far. We have to actually get a particular line according to the I value. It will actually traverse for whole number of lines, and we'll get a single line into line buffer L. And then we have string word array number of tokens is equal to L dot tokens. So for a particular line, I'm getting all the words. Means all the words means these start and this 101. All this stuff I'm actually getting into this word array, and this word array which will be actually storing all those. Now for the size, I have passed the number of tokens. Number of tokens, as you if you remember, I have done made 5, so that max tokens in a particular line can be 5. So yes, I have done that. And L dot tokens will be actually number of tokens in that particular lines which I have stored for the line struct. Now it will get me all those tokens in a particular line like this. Start and 101 will be actually 2 tokens in a particular line, and they will be actually stored in the first 2 indexes of my word array, and all the 3 indexes will be empty. They are string of string type, normal string, and that's why I've used string.h. Now I have to actually traverse all the tokens. J is equal to 0, j is less than number of tokens minus 1, and j plus plus, because number of tokens are actually equal to 5, and if I will traverse less than 5 is actually equal to 4, so that I will traverse actually 5 tokens, 0, 1, 2, 3, 4. That is actually 5 tokens. But in my program I have max say only 4 tokens, so just I will use -1 as the value, and I will just reverse all the stuff. Now in the string w, I have this word j part, means for those 4 tokens I will get first word in this w, and then right in this first word I will get a std string std address is equal to word array I j plus 1. So word array j plus 1 is actually the particular, say, I'm doing something here. Okay, let me explain in some minute. So yes, again coming back. So I'm actually getting the value of this j plus 1, right? J plus 1 can be a string value. So if I will traverse my a single line, then if it is my start, then my particular address will be at the location 1 after it. So I will check for this condition, that yes, if my word dot compare, if my particular word is actually start, then the next after it is actually equal to that address, and the particular address that is equal to 101 in my case, in my source file. So yes, if it is actually equal to start, then I will just do what is get the 101 as the value. Okay, so yes, if I compare this is actually equal to start, then yes, the next one was actually the address. So yes, I will find the all the stuffs into this capital letters. So yes, we have found all the stuffs into this capital letter, so I will compare it with only capital START. And yes, if it is equal to 0, then line number, start line number is actually equal to I, means in among all the lines, if I'm actually traversing with the say I is less than number of lines, right? If starting at a particular line, if I'm actually finding start, then this line it will become my start line, and I in a variable, in an integer type variable int start line number, I will actually store that I value. So we will also print this, that it is actually start is actually found at ith value, and its value is actually start address. That's actually what is actually after start in the tokens. Now I need to actually get the value, right? Now I need to, this is actually a string value, I need to actually get the integer value. So how do we use to typecast in C++? There is a way. There's a class is string, is I string string, and we will pass the value of the string into that class, and then we will use these operators on these operators. That's actually okay, these operator will actually be used to actually parse this string into an integer, and this will place the value of the string into this integer. The integer is actually defined here, and start is equal to 0, and yes, this will give me the actual start address that is equal to 101 and to my variable of start. Now what we will do next, we have found the start till yet. Now I need to actually traverse all the lines from that line. So firstly my work was actually, this is actually a brace which is actually closing this one, and this is actually the brace for this braces. So yes, I am just doing this whole stuff only to get the start address. Now this loop is actually a different one. Now I have to traverse all the lines next from the start. This was the work just to find the start address, and we have found it in the start. Now no need of these all conditions and all or the loop. Now I will just traverse all the stars from this I is equal to start plus 1 and I is less than number of lines I plus plus. Right means from the start line which we have found, start line number is actually being stored in our from that I have got the start line number, and from one line after it I will traverse all the lines which we have found. And then okay, so STL is actually symbol table line. A particular line of that STL is actually being represented by its I part. And then I will set the address to be equal to start plus I minus start line plus 1. This is actually just a simple formula. That is start, what was the start address? And then add the I. In which line you are now, right? The start line will be actually there, and start will was actually the address like 101, and the 101 will be actually added with I, right? I is actually okay, so I think that I must not do anything. This is actually just a I must just increment this value. Okay, so what I'm doing is actually just subtracting this value with the start line plus 1, because the one after the start line will be my zeroth line, and its address will be actually equal to 101. So with the increment of nothing, so this will be actually equal to start line plus 1. This is actually start line plus 1. All will be subtracted will become 0, and start address for the next line after the start will become only 101. But for the next line, this will become start line plus 2, and this will become start line plus 1. The difference will be 1, and 1 will be added with start, that will be equal to 102, and the next line will be addressed as the 102 address line. So the symbol table, I have used the set a line address, set l address, ADR means set line address, and I've used that to actually set the value of its start address. So this for loop is kinda setting the start address, means it is actually acting like a first part of that assembler. If I need to actually show also that line number like this line address, so I can also print it by using the cout statement as cl reference line address, or I can also use a get line address method here. So this might be, I think, printing the start addresses in this way, that here these are the addresses given from that. Firstly 101 is actually found as the start address, then we are actually printing in this way and giving the address to all the lines which we have parsed so far. Okay, so here is it. Now we have done this for all the lines, and this loop is actually giving me all the values there. Now I think the first pass assembler work has been done. So now this all stuff is like a second pass assembler, I think. Now I will need to actually get all the values, like v index must be actually for the variable index, and I am actually using another thing that is equal to variable, right? The variable can be anything now, because we have found on the line addresses. Now our main bug starts for actually generating the object code. So yes, this is actually my index for this variable, and now I will show you this variable struct. This is also another struct which is actually made for all the lines, right? For all the lines we have made this variable, and let me show you this. The variable is also another struct here. Here is my variable. Now I am actually passing its name and its address. So right, we are doing is this for all the variables which we have defined in our source file, so that I can get the actual address of it, so then I can actually store their addresses and they can be used in the object code creation. In these I can see that n is variable, result is variable, one is variable, and term is also variable. So I need to actually get the addresses. I need to actually get the addresses of these ones so that they can be used here in actually inserting all the addresses, because breg or creg can be actually just traversed into the arrays which I have got from the get bc branch codes and get mnemonics to actually get from the static values. But these are all dynamics, and I've actually calculated all the values by just incrementing the lines. But yes, I need to actually make another array in which I can store all these values and their addresses, that is n with some value, result with some value, 1 with some value. So let me actually collect them all. So I've actually made a struct for the sake of simplification. I made a struct with the name and its address. Now it is an integer one, so I will store the actual integral value into its with this name. So these are all being setted, and now I have made another function that is actually str from int. I can actually get cast an integer to a string by using this function. This is actually o string string. That was actually I string string. I stands for input, o stands for output. So it means that yes, I have to get output of string from another variable. So yes, I am actually using x to actually put the value from x to this string output string, and then this string symbol is actually being used in this actually output string symbol, and then I will use this s.str function to actually get the string from whatever is its content. I think I am not using it much. This is actually not a function of this struct. This is actually a global function which I can use, but this is actually a small thing which I can't use without even a function. So where was I was on the variables. Yes, here. Now in this way I'm actually now again traversing all the lines to actually collect all my variables. So start line plus 1, I select the number of lines I plus plus, and then the opcode is actually equal to 0. For this I have actually set another variable that is actually equal to opcode, and I've set its value to be equal to 0. Now the line is again collected into the L variable, and the number of tokens of that particular line are actually being collected into this ARR, which is actually a string array, and it is actually getting elder tokens. And the first word of a particular line will be actually collected with the array 0 part, means this 0 part will actually give me the first word. So for now I'm not actually considering this start variable now, because we have already been traversed all those stuff and we have got the 101 as the value. Now we are also again and again starting from this line index plus 1, and I will only be able to read this read or say move er variable, and most likely these are all the say what's it called opcodes. These are just the operation codes here, for which we have different codes in our file with the get mnemonics function. These are actually the mnemonics here, and if they are not found in mnemonic, that this is a variable. Our logic is that if we will found the first word of our particular line into the mnemonics, then it is actually mnemonic. Otherwise it is a variable which need to be saved with its address. So we have this first word will be equal to array 0 part, and its mnemonic is actually a variable which is actually just used for checking. I will just traverse all the mnemonics as I've tried to explain the logic that if it is found in all the mnemonics that it is mnemonic, otherwise it is a variable. So I will use a variable that it is mnemonic, and the opcode number will be something, and I'm using these ones to actually traverse and find that what are their actual values. Now I will use another found variable here. I will explain it as I traverse this loop. So j will be equal to 0, j is less than number of tokens minus 1, and found is equal to 0, means it is not found till yet, and j plus plus. Right. String word is equal to arg part for a particular thing. I think I'm missing something. First word is actually a right, no issues. Let's see this loop. Okay, so all the mnemonics are actually mne.length. Mne length is actually the number of mnemonics which are defined here in the start, right? we have the mne length, means number of mnemonics here, which I think is a global value. Okay, so that mne dot length needs to be a global value, I think, because yes, we are making this get mnemonics function, mnemonics type, get mnemonic. Yes, here it is, mne dot length. We have got the 11 mnemonics here. Okay, so there is some problem. Mne dot length is actually storing. Okay, so here 0 to 10 must be 11 values. So how, where is it? This must be actually 11, I think, but I will manipulate it because this is actually accessing this mne's 11th part, but it is not saying anything because it is of size 10. I think that I must actually put mne length here, right, so that I can actually have 11 values, so that 10 index can also be accessed. That was some error, I think. Yes. Now let's come again to this part. Okay, so we were at, yeah, this one. Now, now traversing all the mnemonics, right? I will get the opcode is equal to mne opcode. What was the opcode which are actually stored in our all the opcodes? So I will get one by one in the opcode name, and the if the word dot compare means word is actually my j part, and if it something is actually j part means number of I am traversing all the tokens of a particular line, and if I get some opcode means why I'm traversing all the opcodes, I think. Number of tokens minus 1 means I am only traversing 4 opcodes, and I have not found anything yet, right? I have not found any opcode because in a single instruction only there can be a single opcode as far as my instruction set is considered. So there can be only one. So I have used the found variable there. If it is actually set to 1 means I have found at least one opcode in my line, and I don't need to find another one, right? I will just say opcode name is actually equal to mne's opcode. These are in the mn I have all the opcodes being stored, and if word dot compare opcode name is equal to 0 means I have found some opcode, then opcode number will be actually equal to mne's k part, that particular key part's code through this reference symbol, and found will be set to 1, right? So if opcode name is equal to 0 means if first word that compare opcode name is equal to 0 means I have also kept the reference of the first word, and first word also here, like this I've actually got the first word here at the array 0 part, means first word. Why I'm doing this is actually trying to get that first words is actually something like read or something like again. If it is actually found to be in something like opcodes, my opcode array, then it is actually an opcode. But if it is actually not coming in that is opcode will set to 0, and this will be actually stored as a label in the variables array. That's my main logic here. So yes, if it is actually equal to any of the opcode name, then here first word is actually equal to any of the opcode name, then is opcode it will set to 1, then it will be actually set to 1. Yes, true. So this loop is actually running from here to here, and after this loop runs and after all the mnemonics are being traversed, right, then I will see that if found is actually equal to 1 means if it is found in some other opcode, then it is actually good thing that register bcd name is equal to this part. Then I know that after the opcode there needs to be an operand, after the opcode there needs to be some operand. So register or bcd name will be actually equal to that particular j plus 1 part. It means after this loop we have found something, right? After this loop particular thingy means number of tokens while traversing our tokens of a particular line. Like if we have a traverse like something like this move em, then after this opcode, if it is actually found in some opcode, then the next thing must be some register or say branch code like le. So I will store the value into that string variable, I think, because these are all strings. So I will store it into a string variable, and then I will just see out for the sake of debugging that what are those opcode number which we have found. And this is actually simple table lines I part which I'm actually making for the final output uh, array, 2D array. It is like a 2D array, which is actually storing all the stuffs into the output. That's all the addresses plus those opcodes plus those first operand address that might be some register or say branch code, or in the fourth thing that is actually the second operand address. So I'm storing all this stuff into this str, and also the register BCD name. Now I've actually printed all those stuff. So that was might be not useful, and that's why I've cleared this thing. Not cleared. Now name is something and code is something. Those are actually different things. Now our found is actually set to 0. Now I have got the register BCD name. That's actually some variable like this BREG or CREG. A to DREG, I have 4 registers: AREG, BREG, CREG, DREG, and I have got the value in R register or BCD name. That's actually being here. Now I need to actually search for the actual opcode of this, and the codes are actually stored as strings. So I will use a variable that is rfound. If it is actually equal to 1, it will be set to 1, otherwise 0. So yes, and the length is equal to 0, length less than BCD, and found rfound is equal to 0. Until it is found, keep on searching all the all the register values. Then plus plus. Then you will get the opcode name into B name means branch code name and something like that. BC name. I will use the BC length means branch code. I will first find the values into these branch codes, and if it is compared with this name is equal to 0, then its code, which I was actually storing here, will be actually set to branch codes code, and the R found will be actually set to 1. That's yes, its value has been found and it is a branch code, right? So okay, I can actually do the same stuff for these registers. I can make another structure, but this might not be useful so much. So I have used just if condition for if conditions. Okay, so if it is r found will be actually set to 1 if it is actually found some branch code. Okay, so if it is actually, then I will search that if it is it might be another thingy that okay, it might also be possible that it is not a branch code, but it is some register. So if it is actually equal to AREG, then I will set its value to be code to be 01, otherwise BREG, so 02, and if it is CREG, so set 03, and if it is actually DREG, so set 04. Then I will just print out that register code value, and I will set in the symbol table line means the main thingy of our program. I will set the register or the branch code value to be set BCD or REG value, REG BCD code, which we have found in that either it is actually storing some of the branch codes code or some say register code into this, and I will set the first operand to be that. Okay, so now I will need to see that if it is equal to opcode, then it must have been set to 1 because it is found in some of the mnemonics. But if it is still 0, means the first operand is actually not a mnemonic like this. Again, it will be not found in any of the opcodes, but yes, it is another variable, so I need to actually store it into another variable. So I will just print out this thingy at this address, and then this is actually VB is actually my variable array, and the VB index is actually the index for those all the variables, and I will just increment this stuff, and I will create a new variable here, and the first word was actually the word for which is actually found as not being a mnemonic but being an variable, and then I will add the address of that particular variable of the particular line. I have already calculated all the addresses of all the lines, and that's why that's actually being stored in str's get line address, and I will get that line address and I will store this as the second value of this variable, because in the variable structure we have been using the name and the address value. So name will be actually first word that's actually being the again thingy, and its address according to the line number, which will be got by the get ladr. So let me have a look at the variable structure again. So where is that variable structure? Yes, um, where is this variable structure? There are a lot of structure being used. Okay, so it is actually getting a name and its address. So variable will have some name and its address. So yes, we will use those stuffs. We have already calculated the addresses, and we have got the name also, so we can store this stuff with this line. Weeks VB index is equal to new variable, and there can be max say number of lines variable. So I have actually made it according to the number of lines as an array to store actually the number of variables according to the number of lines at max. And if this VB index will be actually incremented, and it will get me all the variables. So this loop will do what? This whole loop will give me what? Where is the loop? Yes, this whole loop will give me what is actually get me all the variables and their addresses so that they can be used in the second pass. So this whole loop is actually performing the first pass of a symbol, and also storing the first operand's address into my STL symbol table line here. Address is already stored. Now the variables name are also being stored into this VB with the number of lines as max value, and also it is actually storing the register or say branch code by using this statement set RGBC. Now but we can also print the variables we found like the V index. I can actually show you. And here in the print statement I can actually show you that which variables are found. After these all line calculation, I have actually found some addresses. So again, is not found in some say all the registers, and that's why it is actually being stored with the address of 104 at this line. And similarly, n is not found, again was not found as a label, so it is actually stored as a my variable array actually stores the labels and the identifiers. So labels is actually stored in 104 as the address, and n is also not found, so it is actually stored with the line address of 113. And similarly for result and other stuff. Now we can actually print the variables found again with the 104 and with 103 and so on, right? So these all stuff have happened. Now let's have a look at it. What is the next stuff? Okay, so this is actually var is actually variable, and its address is var address, which is actually according to the specification of that V index, VB. Okay, so now what is left? Now our second pass is actually needed for actually calculating. We have actually calculated the first operands. Now our second operands are left for all those instructions. Now we will have a look at those. Here is it, lines L will be actually equal to, again we will traverse from the after the start address, start line number and less the number of lines. Yeah, then we will actually get the line with the line main buffer index. I part will actually be stored into this line variable, and then I will get all the tokens of that particular line into my array. Now j is actually equal to 1 and j is less than number of tokens, means I don't need to actually see the first variable. First thingy will be either the mnemonic or say some label, so that has already been resolved already in the previous loop. So I will just traverse from the first to say token -1 first to fourth value, and then j plus plus. Let's get the word is actually array is j part, that particular word is actually there. And then I will see that if it is now what's the trend in my code. Now I'm actually traversing from this value to the end, this value to the end, so it can be actually okay, so this is actually first to the end, and I will see that yes, if it is actually sum of the variable, then I will actually just like this one, print result is actually first value, and it is a variable, and that's why I will store the first operand address to be that. Let's see. So I will use a vFound variable, which will be actually saying that it is found in some of the variables, and it is actually set to 0 because we have not traversed the loop. And let's see another variables which we have used so far. Vindex will actually store the number of variables which we have found yet. So Vindex will be stored the length of all the variables which we have found. And key will traverse all the loop, and we will get the variable value, means name, and its address is also at the second component, which is actually stored in the VB array. Now the if word dot compare is actually a string function which will compare two strings and return 0 if they are equal. And I will compare this var with the word value, and if it is equal to 0 means we have found that variable in that array. So vFound will be actually equal to 1. Vfound will be actually set to 1 if we have actually that particular variable, and the var last will be actually set to var, means last variable which was found will be actually set to var. I don't know why I'm using it. And that var address will be actually, this particular address will be actually equal to say v's var address, and then this loop will actually break up. if we have found this will actually search for all the variables and will actually set to be found to 1, and is also addressed to var address. Now after this loop traverses, this loop actually traverses from this place to this place, and if it is actually equal to 1, means we have found the particular first operand. We have found say the operand. We have found the first operand to be say first, or say later operand, some operand in my line to be in my variables. Then yes, it will be set to 1 and it will come to this if condition. So I will see that I need to actually set the address into my symbol table line. So set the last var address. Okay, so last var address will be actually var. That means I'm actually looking for the last variables here. These registers have been set it up, but these last things are being considered in this loop. So one is also a variable for which we have found it in the variables, because we have already stored in the variable array these all stuffs. And for one, while looking for the one, we have to see that one is actually found in one of the variables. So this is actually the last thingy in our symbol table, and we will actually set its address in the symbol table line, last var address to be var address, right? Then we will see that what has been set at last var address, because this is the last thing which need to be set up. Now I will all thing has been done. The second pass will traverse all the stuffs like one term, one term, and then n, and then again is also found in variables, because the variable also stores the labels, then result, and all this will be actually referenced, right? All these things will be referenced, and I'm not actually traversing the first thingy, right? Because the first thingy will be the variable name, and that's why when it will come to these condition, right, when it will come to this condition, then saying the ds, or say 1ds or 1 or dc or 1 will not be found in any of the variables, right? And that's why I am not traversing from 0, I am traversing from 1, so that I can actually only have a look at these variables, 1 and 1, or not, and not the these, right? Because I'm actually traversing this loop, you can see, from say where it is, from 1, right? Here is it. I'm actually traversing this from this 1 index. So now I will need to actually, what I have got so far in my symbol table line array, I need to actually write it somewhere. So I will create another file that is actually symbol.obj, and I will just see out there to be see out in the console to be print statement, and also in that file with the reference with these string symbols I will write their symbol table, right? And from the next line, from the start line plus 1, from the start line plus 1, I will start writing for the lines. I will first put a new line there, and then I will just compare. If scl.opcode.compare is equal to 0, means if we have found okay, so if we have found some opcode in our process before, like passing, if you have found some opcode, means if it is stored with some opcode, then it is equal to it is fine. Otherwise we will set its opcode to be 0, so that it won't leave it empty. And if we will also find this is register or branch code to be 0, means no register or branch code was found for this instruction, then we will set to 0 0 0. And if we have found the last var address to be equal to 0, means we have not compared it with string, because we are using integer as its last var address, then we will set it to 0 0 0, right, according to our instruction set, because we have three digits to represent the address, because we are using some stuff like that. I think I'm using hex here. So okay, means like 12 bytes. Okay, so string last line address string in the string, ladr means line address in string format, is equal to string from int. I need to actually write strings in this file, so I need to actually get the string from int. So I'm using string from int, the function which I have shown you before. That's actually a global function. St else ipart.get ladr means get the line address, and I will get the line address and pass it through the string from int. So this is actually a integer, and it will be typecasted to a string through this function by using the iString class. I think the OString, yes, OString string class, right? You need to also include this header file here. That's actually your S string for the I stream and the O stream classes. You need to actually define the S stream.h file. So yes, we were at this place. We are just going to end up this long session. So where was that? Yes. Okay. So we have to actually get the line address in the form of string by this method, and we have to actually get the line last word address also from integer. We are storing it in the form of integer, so we will typecast it to the string by using the same global function. And if it is actually found, okay, so the last where address is actually found to be 0, then it will be also set to, if I am actually not finding the last where address to be anything, then I will just make it to be 000, because it will look good in our 3-bit representation, or 3-digit representation, not bit, are actually 12. This is hex representation. Now we will just see out, and also I will do the same in my file. What I will do is, firstly my printing stuff will be actually the line address, and then there the bracket, and then we will use a tab space, and then I will print the opcode what I found so far, and then I will print the register or the BCD code in the string format, which we have stored in the where is it? Okay, so it is already string, so we don't need to typecast it or get the string out of integer. And then last where address, which we have already converted to a string. So I will print all this stuff, and I need to actually close this stuff, and this is done. In this way my Thunder processor works, right? So yes, it was a long program, and sorry for that, for the long session. And yes, okay, so in this way it will print all those stuff into this console, and also into another file. So let me show you. So it must have made a symbol.obj file, right? And let me actually show you it where the, sorry, let me, where is it? Okay, let me show you with Sublime Text. Yes, it is my symbol.obj file. It will first print the symbol variable there, as I have mentioned before, and then it will print the addresses, and then there are bracket and then plus. Then these are actually the opcodes which it had found so far, and then is actually the first address, and then this is actually the third address. As you see in the source file, for the first one we have only one address, and that's actually not a branch code or a register value, and that's why this field is actually empty. And the third address means the second operand address is actually 113, and 113 is actually used for n. So it is actually storing all this stuff up, right? And talking about the stuff, it is not actually, after the result, it is not actually using any operand. So yes, in the stop also, I think that it is actually 1112, and 113 is for, okay, 114 is actually for less value, right? In this source fine, right? So we have these values there, and then okay, we are not using anything here. We will just mark a 0 by using those if conditions. If it has not found anything, then they are being set it. If it has not found anything, then they are being set it to the default 000 values according to these conditions which you have seen, right? And a file like this will be generated, right? A file like this will be actually generated. So okay, so it is done. And for the variables, they doesn't have any operand values, so they are just set to 0 in our hypothetical assembler. So okay, in this way this program is working. The code will be found in link in the descriptions below. Thank you for the long session. I'm sorry I didn't split it. I want to do it in one video. So yes, that was all about the C++ program. Runs fine and gets you the code for the hypothetical language. Thanks a lot.